Hi everyone, in this video we're going to be talking about the law of sines, which is a way to find the sides and angles of a triangle when that triangle is not a right triangle. So let's go ahead and get started. So we'll want to use it when we are trying to solve a triangle. And by solve a triangle, I mean find the remaining sides and angles. But we can't do it in all cases. We can only do it when we have certain information. So we can do it when we have, and the info we have is two angles and a side. So we can do it if we have angle, angle, side, or angle, side, angle. And we can also do it if we have two sides and the angle opposite them. So what I mean is if I have angle A and angle B, and then side A, that would be angle, angle, side. Two angles in a row and then the next side. Or I could have angle, side, angle, so I could have angle A, side C, and angle B. We'll see some examples. And I didn't mean to put a 3 there, so you can ignore that 3. So what does the law of sines say? First of all, let me just point out the notation in this triangle. My angles are labeled with capital letters A, B, and C. A, B, and C. My sides are labeled with lowercase letters. So little a is the side opposite angle big A. Little b is the side length opposite big angle B. And little c is the side length opposite angle C. And notice that this is not a right triangle. So what does the law of sines say? It says that if you take the ratio of the side length A over the sine of angle A, and you take, that will be the same as the ratio of side length B over sine of B, sine of this angle, which is also the same as, you guessed it, side length C over sine of angle big C. And that's true for either of these types of triangles. It doesn't matter if the triangle is acute, so acute meaning all the angles are less than 90, or obtuse, meaning one of the angles is bigger than 90. So let's see how we actually use this law of sines. In this case, let's first look at the information that I'm given. I'm given that angle C is 102 degrees, angle B is 29 degrees, and side B, little b, equals 28. And that's not degrees, that's a length. So the information I have is angle, angle, side. And so what I want to do is I want to find all the other angles and sides. But with this information, b and little b, and then capital C, I can use law of sines to find little c, because b over sine b equals c over sine c. So I'll just fill this in, and I see, so little b is 28. Sine of b will be sine of 29 degrees. Little c is what I'm looking for, and sine of big C will be sine of 102 degrees. So now I can just plug this into my calculator, and that will allow me to solve for C. So I'm just going to cross multiply. 28 sine 102 degrees will equal sine of 29 degrees times C. And so C is going to equal 28 times sine of 102 divided by sine 29. So first, notice I'm in degrees, so I better switch my calculator into degree mode. And now I can solve this. So I'll do 28 times sine 102 and divide that by sine of 29. And that gives me 56.493 equals length C. So now the only things left to find are big A and little a. So to get big A, I know that the entire triangle adds up to 180 degrees. So I'll have 180 equals A plus 29 plus 102. And I can plug this into my calculator. 180 minus 29 minus 102. I find that big A equals 49 degrees. So now I'll use law of sines again, but I'll use the A over sine A ratio to get little a. So I do A over sine of 49 equals, and I could use B over sine B or C over sine C. I'll use B over sine B because that was the information that was given to us at the start. So little b is 28. Sine of B will be sine of 29 degrees. By cross multiplying, I will find that A equals sine of 49 times 28 over sine 29. So we put that into our calculator again. Sine of 49 times 28 divided by sine 29. And I find that little a equals 43.588. And this seems pretty reasonable. Side C should be the longest since it's opposite the longest side. Side A should be longer than side B because angle A is bigger than angle B. So it's reasonable. Now let's use the law of sines in this obtuse triangle because I have an angle that's 98 degrees. So the information I have is angle, side, angle, because I have angle B, side C, and angle A. So I have angle, side, angle. But I actually have a little bit more information because I can easily find out C. So to find angle C, I'll do 180 minus 98 minus 43. 180 minus 98 minus 43 is 39. So C is 39 degrees. So let me fill that in. And now I have angle, angle, side. And that is pretty useful to me because I want to compare the sine of angle C to side C in order to get any of the other values. So maybe next we should do little b. So to do little b, I need to say b over sine of big B equals C over sine of big C. So I fill that in. B, I don't know. Sine of B is sine of 98 degrees. C is 22, since that's given to me. It's opposite C. And sine of C will be sine of 39 degrees. So again, by cross multiplying, this tells me that B is going to equal sine of 98 degrees times 22 over sine 39 degrees. And I'll plug that into my calculator. 22 times sine 98. Divide that by sine of 39. And I get 34.618. Okay, so now let's do length A. So to do A, I need to use A over sine A. And I can use either B over sine B or C over sine C, but let's do C over sine C again. So we'll have A over sine of 43 degrees, since capital A is 43, equals 22, since that's the side opposite capital C, sine of 39, since 39 is angle C. So that tells me A equals sine of 43 degrees times 22 over sine of 39. And I plug that into my calculator once more. So sine of 43 times 22 divided by sine 39. And we get that A equals 23.842. So these are just two simple examples for how to use the law of sines. It's really simple once you have labeled your triangle appropriately and know where to plug things in. We'll do some more complicated examples when we talk about cases where the law of sines needs to be tweaked just a little bit in order to work.